Greetings everyone! Our main focus for this video presentations is the lymphatic system and the drugs recently discovered for it. And this will be the components of these video presentations. This system is a network of tissues and organs that primarily consists of lymph vessels, lymph nodes, and lymph. These lymph are like colorless, clear fluids that contain white blood cells that aid in getting rid of the body toxins, waste, and other unwanted materials from the body. Our lymph nodes are very important in the body's immune system. They are the ones responsible in fighting the infections. These lymph nodes acts as a filter for the limbs in catching the debris or cells that are present within the lymph. The lymphatic system's main organs are the tonsils, our lymph nodes, our thymus, and the spleen. One of the diseases in the lymphatic system is lymphoma. This is the cancer of your lymph nodes. The lymphocytes, a special type of white blood cells that fight off the infections, begin to grow and multiply out of control. Lymphomas can be classified as Hodgkin's or the non-Hodgkin's type. Illustrated here are the common signs of having lymphoma: the swelling of your face or neck, lump in your lymph nodes like neck, armpits, or groin, excessive sweating at night, and itchiness. A rare disease in the lymphatic system is the Castleman disease. It is an inflammatory disorder where the lymph nodes become enlarged and can cause multiple organ dysfunction. It can be classified as unicentric, applying on one lymph node, or multicentric, involving other multiple lymph nodes. Another one is the SLE, systemic lupus erythematosus, which is an chronic autoimmune disease where our immune system also attacks its own healthy tissues. As of now, there is no cure for SLE, but the goal of the treatments is to ease the symptoms and the inflammation. The general characteristics of the drugs acting on the lymphatic system are that they are highly protein bound, thus less free drug, less therapeutic effect. Some of the drugs are also fastly metabolized by the body and cleared out of the system. Some of them have narrow therapeutic index. With a slight difference in dose, it could lead to fatal results. So for several decades, scientists, drug manufacturers, designers, and pharmacists have extensively researched of the drug delivery system appropriate for the lymphatic system. Now they can opt for the liposome-based or polymer-based drug delivery system, where they can passively target or utilize antibody-based immune therapy, which is more specific in targeting parts of the lymphatic system. Chosen our topic of medicines based on each type of nanotechnology applied. First is the Vincristine Markibo liposomal injection, an anti-neoplastic agent. Next is siltuximab silvant, a monoclonal immunoglobulin anti-neoplastic for multicentric Castleman disease. And lastly, a recent discovery on cyclosporin A as immunosuppressants. One of the drugs acting on the lymphatic system, especially the bone marrow, is the Vincristine Markibo, a liposomal injection, a novel drug delivery system by the Acutec Biopharma LLC. Decades ago, scientists were trying to find out the extracts of these periwinkle plants for anti-diabetic properties. However, they discovered that these Vinca alkaloids had anti-tumor properties, vinblastine and vincristine, and its other derivatives. But our focus today is Vincristine, which is also a highly cell cycle dependent anti-cancer drug. For years, clinics have been using this as treatment for different types of malignancies, namely the lymphomas and breast cancer. However, its use has been limited in the practice because of its severe neurotoxic effects. In dire need, the US FDA approved Markibo on August 2012 with a therapeutic indication for Philadelphia chromosome-negative acute lymphoblastic leukemia in second or greater relapse, or whose disease have progressed even after 2 or more anti-leukemia therapies. Vincristine acts on the mitotic phase of the cell cycle. Vincristine binds to the tubulin that forms dimers and needed in the polymerization of the microtubules. Microtubules are important because they help in stabilizing and anchoring the parts needed in the spindle apparatus, after which the chromosome stops segregating and triggering the hindrance of metaphase, and thus the mitosis stops. However, in the case of Vincristine Markibo, the active ingredient is encapsulated in a layer made up of sphingomyelin and cholesterol-based liposome. With this system, the drug is able to be distributed widely within the tissues of our target organs. Markibo comes in sets, and it has to be prepared 60 to 90 minutes. The prepared product should be given only intravenously at a dose of 2.25 mg per meter squared over 1 hour once every 7 days. Markibo kits comes with 3 vials, which are named here. When prepared, each single dose vial contains 5 mg per 31 ml of Vincristine. The dose can be modified if the patient is starting to show signs and symptoms of dysfunction of the nerves or neuropathy. This should be avoided by CMT syndrome, characterized by peripheral neuropathy, hypersensitivity, and death had occurred during intra-apical administration. As you can recall, Vincristine is encapsulated in this SM cholesterol liposome with a ratio of 60-40 moles. In the neutral pH extramedium, the basic Vincristine is able to diffuse within the acidic environment of the liposomal medium. Because of the Vincristine's steric build, it cannot pass through within the interior of the liposomes. Heat is then introduced to disrupt the bonds within the liposomes and enable the entrance of the Vincristine. As the lipids cools down, a spontaneous self-reassembly happens, and this traps the Vincristine within the membrane. With this system, Vincristine can be slowly released until they reach the tissue target. Because of its small diameter, there is also low protein binding. The data shows the significant difference of how high the concentration of the VSLI compared to the VCR in the different target areas. The Vincristine liposome has a higher tolerated dose compared to the simple VCR. At this table, this shows the difference of the anti-tumor activity of the VCR and VSLI to the different types of xenografts. As technology advances, more of the scientists and drug designers incorporate this in creating different types of liposome nanotechnology. To wrap up my presentation, we can all look back to the past where liposomes have been extensively researched, theorized, and because of the advanced technology, we're able to reach this type of delivery system. Whether the drug is lipophilic, hydrophobic, amphipathic, or highly toxic, we are able to modify its mode of transportation, enabling us to lessen the toxicity of the drug or protect its activation by the body. But some problems are still present within the system. Some preparations become unstable because of the easily oxidative properties of these natural phospholipids. The cost of production also increases the selling price of these products. Thank you, and please help yourselves in reading some of these references.